So where we left off last time is where we talked about heating curves and cooling curves. So when we look at this, what we're seeing is energy being added. And here's what's happening to the particles on each step. When we see an incline, so from A to B, particles are heating up. They're getting more whooshies. They're getting more speed. Then when we hit a plateau, like between B and C, they're starting to space out. So in here we have melting, right? We're going from a solid, we're going to a liquid. Then we hit another incline and things start to speed up. Another plateau, our liquid's turning to a gas. And then finally, our gas is starting to speed up even further. It's starting to get more temperature. Inclines mean increased temperature. Plateaus mean that things are spacing out. Now that's a way to talk about things in a very qualitative way. So now we need a way to talk about this in terms of quantities. So we use these things called LOL charts. So we're going to talk about two different things. We have EPH, which is phase energy. Now, phase energy is where things spread out or come together. So it's changing the space. In other words, we're changing the state of the item that is there. Then we also have ETH. This is thermal energy. Or we can say temperature, right? So it's getting either hotter or colder because it's talking about the speed of those particles. So let's just look at temperature for a moment. So let's look for areas where we're starting to see a temperature change. Now we know where we're starting. We're starting off with a nice cold substance. So we have one block for ETH. If I was at 0 degrees Kelvin, where there's no movement, no speed, no motion, then that would have no bar space. But since we're not at 0 degrees Kelvin, we're at negative degrees Celsius here, then we have some energy. So we have to account for that. Now as we go to B, so as we move up, we're gaining temperature, we're gaining speed. So I have to account for that. So I'm going to make two squares here to show that I've increased my temperature. Now when I go from B to C, I don't increase temperature, so I don't add any more bars. I'm not raising the temperature. But when I go from C to D, I do again, right? I increase that temperature, so I'm increasing. I'm on an incline, so I'm increasing that temperature. From D to E is a plateau. There's no increase, so I keep the temperature the same on that bar chart. And then lastly, we get a nice hot gas here, so we're going to increase all the way up, all the way to our fourth column here. So everywhere that there's a gain in temperature, an incline, I'm adding a little cube of energy on there. Now with phase is where things spread out. It's a solid. So right now, because it's a solid, we say that it has one thing of phase energy to it. Now, we did not change it. It's still a solid at B, so we still only have one cube of energy. As we go from B to C, this is where things change. This is where my object melts. So it's going to now be a liquid. So it has more space. So I'm accounting for that space there. As it goes from C to D, it's still a liquid. It's just getting warmer. But when I go from D to E, that's where things change. That's where we get more energy added in. And now to make it a gas, we have to add a lot of energy. So we're actually going to say that gases have 4 cubes. So gases always have 4. Liquids have 2. Solids have 1. And then in our last step here, we still have a gas. So we're going to have 4 cubes here. And what you'll notice, and we use the analogy of this being like a checking account. You can either put things into your checking or your savings, but you can only do one transaction at a time if you're at like an ATM machine or something. So right here, I can only add a little bit of thermal energy. Over here, I'm going to add a little bit of phase, but my thermal stays the same. Add a little bit more thermal, add a little bit more phase. Add a little more thermal. So I'm doing one thing at a time for each step because only one thing's happening. I'm either increasing the temperature or I'm increasing the space. In this particular case, if it was a cooling curve, I could be decreasing those things, right? And this whole time, we're adding energy. So we're going to add some energy here. Because I'm putting energy into the system at every step. I'm not taking any out. How much energy did I add? Well, I added 1 red cube. Over here, I added, so that's what I got here. Over here, I'm going to add 1 purple cube. And you don't have to do it with colors or different things, just one, and then we're just saying one quantity of energy, right? So we're just putting one chunk of energy into our system. And that's how we can start to talk about things in a quantifiable way. I'm adding energy, I'm adding a chunk. So we can say that there's definitely a positive relationship here. If this was a cooling curve, it would literally just be the opposite. We would just be going backwards, and our terms would change. If we were going backwards, we'd be cooling down that gas, condensing into a liquid, cooling down that liquid, freezing to a solid, and then continuing to decrease the temperature of that solid. And it would literally be this, but backwards. And then we would have our arrows pointing out of the system, okay? So let's continue to try this, try the practice that I've put up on Classroom, and keep working hard. Have a great vacation, everybody.